first thing you guys should do is draw a cone. And surface area is pi r squared plus pi r, this weird little L shape, which means slant height. So we're going to start with that. Here is my 3D, I'm going to try to do it so you can see both. Here's my 3D cylinder, and here's my 3D cone. Okay, so we talked about for surface area of a cylinder, we've got the area of the top, the area of the bottom, and the area around the sides. Okay, so for a cone, for a cylinder, I have two circles, one on the top and one on the bottom. Do we see that we only have one circle on the bottom for a cone? Okay, which is where the pi r squared came from. Now we're going to talk about the pi r slant height, okay, and what that means. So we're going to start with what slant height is. So we're going to move over and we're going to say slant height equals, and talk about what slant height is equal to. Okay? Now, what is slant height? So if you're looking at a cone, guys, what do we think the slant height would be on this versus the height? So from the bottom to the point, from the center to the bottom to the point, or from along the edge? Okay, that's what we're talking about when we're talking about slant height. And you're going to have to go back and forth with these about what slant height is and so on. Okay, so when we're talking about slant height, it becomes a right triangle. So do we agree? If I put this pen in here like this, it's kind of hard to see on here. But do you guys see how I'm making a right triangle? The pen to the green part on the bottom to the yellow part on the side, we make a right triangle? Okay. So if we're looking at that right triangle, this is the height, this is the slant height, and this is the radius. Okay? So we go slant height squared equals r squared plus height squared. Okay? We can just stick it all in at once, right? Like if I wanted to put this really quick into a calculator, what could I do to this equation to just put it into calculator all at once? Yes, Michelle?
The square root of r squared plus h squared.
Yeah, I'm going to take the square root of both sides, and then I'm going to get the slant height equals the square root of r squared plus h squared. Okay? Sometimes it'll give me the slant height. Sometimes I will have to find it. Okay, but then I'm going to use this equation. All right. We're going to start with finding the surface area of a cone where it gives me the slant height, because I think that's a little bit easier. Okay? So your equations are right here at the top of your paper, as well as we just put them in a circle book. Okay? So I'm going to look at this and I'm going to label these things. Okay, I know 10 is my slant height. I know 2 is my radius. Now I want to put it in this top formula right here. So I'm going to write pi 2 squared plus pi 2 slant height. And I'm just going to stick it in my calculator. It's, the same plug and chug we were doing for cylinders, just with a different formula. And we're going to get, we need to I think we should probably round to the nearest hundredth or tenth. In this case, I'm going to do tenth. 75.4 centimeters squared. Remember, we're talking about area, so everything should be squared. Do you guys feel pretty confident in that, or should I try one more? Good? Okay, let's do one where you have to find the slant height. So let's look at number one. So the first thing I'm going to do is I'm going to use that slant height formula. The slant height equals r squared plus h squared. Do you see how there's no number on the outside? Okay. So I'm going to say slant height equals the square root of 27 squared plus 49 squared. Just stick it in my calculator. Square root 27 squared plus 49 squared. And I get the slant height equals 54.6 inches. Now I'm going to plug it into my surface area formula, which is pi 27 squared plus pi times 27 times 54.6. And I get 6,921.6 inches squared. Yes? Okay. I would like you guys to try 4 on your own, and then we're going to go over it just because I want to check to make sure that you're getting the right answers and plugging into the right formula. So number 4 on this side, right here, because it doesn't have a slant height, I want you to try that one right now. Yes. Okay, so let's try this together. If you have a question as I'm going over it, please raise your hand. Okay. I'm going to start with finding the slant height. So I'm going to go the slant height equals the square root of 17 squared plus 6 squared. So again, I'm going to put that in my calculator. 17 squared plus 6 squared under the square root sign. And I get, I'm going to say it is approximately 18. Because if we round to the nearest tenth, that's how far it goes. Okay. Once I have that, I'm going to plug it into the formula. I'm going to say pi 6 squared plus pi times 6 times my slant height. I'm going to put that in my calculator. We go pi 6 squared plus pi times 6 times 18. And I get 452.4 meters squared. Anybody have a question about that? Yes.
I think number 1 is wrong.
I think number 1 is wrong too.
I got 7,036.
Let me check my answers. Okay. So let's start with my slant height. It is definitely possible that I plug something into my calculator different. It is also possible that my calculator rounds differently than yours does. Okay, so I'm gonna redo the slant height first. I'm gonna do the square root of 27 squared plus 49 squared. And I get 55.9. Or 56 is what I would round it to. So let's change this to 56 and see if we get a different answer. It's very important to tell your teacher when you think she's wrong. Or he. So that we don't teach the rest of our classes the wrong way. And so that there's oftentimes, I did not in this case, but there's oftentimes when your teachers make mistakes on purpose to see if you'll catch them. Oh, that's much better.
So you made this mistake on purpose?
I did not do that this time. This was an accident. 7,040.31 inches squared. Is that better? Okay. So we've done 2 examples. Should we do a third, or you guys feel pretty comfortable?
Yeah.
Okay. Let me go over this because there's a lot of mistakes like this on the homework last night. Is 6 inches the radius for this?
No.
That's the diameter. Make sure you take half. Okay? Remember, the front is a lot easier. You just plug it into the formula. You do not have to worry about finding the slant height for anything on the front. The back you do for some, for others you don't. Okay? Any other questions before I stop recording? Okay. You have extra time to now work on your work.